Hi everybody, in this video also we are discussing the questions from the chapter Equilibrium which were asked in the previous year Neet entrance examinations during the period 2020 to 2024. Please listen. Now question number 1. 3O2 gas reversibly gives 2O3 gas. For the above reaction at 298 Kelvin, Kc is found to be 3 into 10 raised to minus 59. If the concentration of O2 at equilibrium is 0.04 molar, then the concentration of O3 in molar is option number 1, 1.2 into 10 raised to 21. Option number 2, 4.38 into 10 raised to minus 32. Option number 3, 1.9 into 10 raised to minus 63. And option number 4, 2.4 into 10 raised to 31. Listen, here the given reaction is 3O2 gas reversibly gives 2O3 gas. Its equilibrium constant Kc is given, which is equal to 3 into 10 raised to minus 59. And the equilibrium concentration of O2 is also given, which is equal to 0.04 molar. We know equilibrium constant Kc is equal to concentration of O3 square divided by concentration of O2 cube. Here Kc is equal to 3 into 10 raised to minus 59, which is equal to concentration of O3 square divided by 0.04 cube. Now cross multiplying this equation, we will get 3 into 10 raised to minus 59 into 4 into 10 raised to minus 2, the whole cube is equal to concentration of O3 square. That is, concentration of O3 square is equal to 30 into 64 into 10 raised to minus 64. So concentration of O3 is equal to square root of 30 into 64 into 10 raised to minus 66. That is equal to 5.48 into 8 into 10 raised to minus 33. By calculating this, we will get the final answer 4.38 into 10 raised to minus 32 molar. So here the answer is option number 2. Then question number 2. The equilibrium concentrations of the species in the reaction A plus B reversibly gives C plus D are 2, 3, 10 and 6 moles per liter respectively at 300 Kelvin. Delta G0 for the reaction is, in bracket, R is equal to 2 calories per Kelvin per mole. Option number 1, minus 137.26 calories. Option number 2, minus 1381.80 calories. Option number 3, minus 13.73 calories. Option number 4, plus 1372.60 calories. Listen, here the given equilibrium reaction is A plus B reversibly gives C plus D. The equilibrium concentration of A is given as 2 moles per liter, B is equal to 3 moles per liter, C is equal to 10 moles per liter, and that of D is equal to 6 moles per liter. Here in this reaction, equilibrium constant Kc is equal to concentration of C into concentration of D divided by concentration of A into concentration of B, which is equal to 10 into 6 divided by 2 into 3. Therefore, here Kc is equal to 10. We know the relationship between the standard free energy change delta G0 and equilibrium constant Kc, which is delta G0 is equal to minus 2.303 RT log Kc. Here R is equal to 2 calories per Kelvin per mole, temperature T is equal to 300 Kelvin and Kc is equal to 10. Substituting these values, the equation becomes delta G0 is equal to minus 2.303 into 2 into 300 into log 10. Log 10 is equal to 1. Therefore, it is equal to minus 2.303 into 600. That is equal to minus 1381.8 calories. So here the answer is option number 2. Now question number 3. In which of the following equilibria Kp and Kc are not equal? Option number 1, PCl5 gas reversibly gives PCl3 gas plus Cl2 gas. Option number 2, H2 gas plus I2 gas reversibly gives 2HI gas. Option number 3, CO gas plus H2O gas reversibly gives CO2 gas plus H2 gas. Option number 4, 2BrCl gas reversibly gives Br2 gas plus Cl2 gas. Listen, we know for a reversible reaction, the equilibrium constants Kp and Kc are related as Kp is equal to Kc into RT raised to delta n. Here Kp is equilibrium constant in terms of partial pressure, Kc is equilibrium constant in terms of concentration, R is a gas constant, T is a temperature, and delta n is a change in number of moles. Change in number of moles means number of moles of products minus number of moles of reactants. When delta n is equal to 0, Kp is equal to Kc. When delta n is not equal to 0, Kp is not equal to Kc. Here in this question, we need to find out the reaction for which delta n is not equal to 0. In the first option, number of moles of gaseous products is equal to 2 and that of the reactants is equal to 1. Therefore, delta n is equal to 2 minus 1, that is equal to 1. And in the remaining cases, that is option number 2, 3 and 4, delta n is equal to 0 because the number of moles of gaseous products is equal to and that of the reactants also equal to 2. So here the answer is option number 1. Now question number 4. For the reaction 2A reversibly gives B plus C, Kc is equal to 4 into 10 raised to minus 3. At a given time, the composition of reaction mixture is concentration of A is equal to, concentration of B is equal to, concentration of C is equal to 2 into 10 raised to minus 3 molar. Then which of the following is correct? Option number 1, the reaction is at equilibrium. Option number 2, the reaction has a tendency to go in forward direction. Option number 3, reaction has a tendency to go in backward direction. Option number 4, reaction has gone to completion in forward direction. Here the given reaction is 2A reversibly gives B plus C. Here equilibrium constant of the reaction Kc is given, which is equal to 4 into 10 raised to minus 3. At a given time, concentration of A is equal to concentration of B is equal to concentration of C, which is equal to 2 into 10 raised to minus 3. So we can calculate the concentration quotient Qc, which is equal to concentration of B into concentration of C divided by concentration of A square. That is equal to 2 into 10 raised to minus 3 into 2 into 10 raised to minus 3 divided by 2 into 10 raised to minus 3 the whole square, which is equal to 1. Listen, here the equilibrium constant Kc is equal to 4 into 10 raised to minus 3 and the concentration quotient Qc is equal to 1. That means Qc is greater than Kc. If Qc is greater than Kc, then the equilibrium will shift towards backward direction. That means here the answer is option number 3. Now question number 5. Consider the following reaction in a sealed vessel at equilibrium with the concentration of N2 is equal to 3 into 10 raised to minus 3 molar, O2 is equal to 4.2 into 10 raised to minus 3 molar, and NO is equal to 2.8 into 10 raised to minus 3 molar. The equilibrium reaction is 2NO gas reversibly gives N2 gas plus O2 gas. If 0.1 moles per liter of NO gas is taken in a closed vessel, what will be the degree of dissociation alpha of NO gas at equilibrium? Option number 1, 0.00889. Option number 2, 0.0889. Option number 3, 0.889. Option number 4, 0.717. Listen, here the reversible reaction given is 2NO gas reversibly gives N2 gas plus O2 gas. Equilibrium constant Kc is equal to concentration of N2 into concentration of O2 divided by concentration of NO square. Here concentration of N2 is given as 3 into 10 raised to minus 3 molar, concentration of O2 is equal to 4.2 into 10 raised to minus 3 molar, and the concentration of NO is equal to 2.8 into 10 raised to minus 3 molar. Therefore, Kc is equal to 3 into 10 raised to minus 3 into 4.2 into 10 raised to minus 3 divided by 2.8 into 10 raised to minus 3 the whole square, which is equal to 1.607. Now in the second part of the question, it says that 0.1 mole of NO is taken in a closed vessel. we need to find out its degree of dissociation at equilibrium. That is, now the initial concentration of NO is equal to 0.1 mole per liter. Then the concentration of N2 is equal to 0 and O2 is also equal to 0. If alpha is a degree of dissociation of NO at equilibrium, the degree of dissociation means the fraction of moles dissociated out of 1 mole. That means if 1 molar NO were taken initially, then alpha molar of NO will be dissociated at equilibrium. Now the concentration of NO becomes 1 minus alpha, and that of N2 and O2 becomes alpha by 2. Since the initial concentration of NO was 0.1, its equilibrium concentration becomes 0.1 into 1 minus alpha, and that of N2 and O2 becomes 0.1 into alpha by 2. Now the equilibrium constant Kc is equal to 0.1 into alpha by 2, which is the equilibrium concentration of N2, into 0.1 into alpha by 2, that is equilibrium concentration of O2, divided by 0.1 into 1 minus alpha the whole square, which is the concentration of NO at equilibrium. Therefore, Kc is equal to alpha square divided by 4 into 1 minus alpha the whole square. But here Kc is equal to 1.607, so it is equal to alpha square divided by 4 into 1 minus alpha the whole square. Taking square root on both sides, the equation becomes 1.267 is equal to alpha divided by 2 into 1 minus alpha. That is 2.53 is equal to alpha divided by 1 minus alpha. Then cross multiply, 2.53 minus 2.53 alpha is equal to alpha. That is 3.53 alpha is equal to 2.53. Therefore, alpha is equal to 2.53 divided by 3.53. That is equal to 0.717. So here the answer is option number 4.